Assalamu alaikum warahmatullah. In this short video, I'm going to discuss the concept of a bond duration, and later we will also discuss the bond convexity, both which are important measures of bond interest rate risk. So one of the major risk factors that bonds are exposed to is the changes in interest rates. And to capture the sensitivity of the bond to this risk, we need to look at its duration. Now, what is the duration? The duration is a measure of how long the holder of the bond has to wait before receiving the present value of cash payments. So remember, the bond price that we observe is basically the cash flow or the coupon payments the bond holder will receive, discounted to today's value, and that also includes the last coupon payment and the face value of the bond. Now, important note here is that we are discounting these cash flows using the bond yield to maturity, instead of using the zero rates, which we learned in chapter 4. Because also this is one standard practice that people in the industry use, is to use the bond yield to maturity to discount the future cash flows. Both whether you use the zero rates, or the current zero rates available, or the bond yield to maturity, you should get the same price for the bond. Now, we can define the duration as a sum of the time at which the cash flow is going to be paid times the cash flow or the present value of the cash flow discounted by the bond price today. So in a way, we can interpret the duration as the bond's average life. Now, if we got the duration of the bond, then we can predict by how much the bond price will change as a result of a certain change in the bond yield. So all what we need to do is have the bond price now, what is its duration, and what is the change in the yield that we expect or that we anticipate. This here is the same expression as in the left. It just tells us by how much, what's the percentage change in the bond. Here it will tell us what is the dollar change in the bond. Let's look at an example. Now, a 3-year 10% coupon bond with a face value of 1,000. The current yield on the bond is 12% per annum with continuous compounding, and coupon payments are made semi-annually. How will the price of the bond change as a result of a change in the yield by 10 basis points? So if you remember from the beginning of chapter 1, what is a 1 basis point? So a 1 basis point is basically 0.0001, which means 10 basis points is equal to what? So this is 1 basis point. 10 basis points, 0.00. To find the duration, we need to organize the inputs to get the duration. One way is to do this by using a table. In this table, we will have a column for the timing of the coupon payments or the cash flows that the bond will produce, And here we have the cash flows. Since the bond pays 10% and the payments are made semi-annually, then every 6 months the bond will yield or will provide its holder with $50 coupon payments. Then we need to find the present value of the cash flows. Then we need to find the weight, which is basically the present value of the cash flow divided by the bond price. We get the weight. Then we multiply the weight by the time in which the payment will take place, and we will get the last column. The time times the timing of the payments times the weight will give us the last column, and if we add them together we will get the bond duration. So 2.653, what does this tells us? Now the maturity of the bond is 3 years. The holder of the bond will get the price of the bond, the present value of the amount, the cash flows he will receive today. He will pay back, in a way, he will pay back the bond after 2.653 years, which is logical because the investor is receiving coupon payments, so he will be able to retrieve a large part of this investment in the bond before the end of the 3 years. Okay, now we found the bond duration, which is 2.653. Now we want to see how the bond price will change if the yield changed by 10 basis points. Let's say the bond yield increased. So if the bond yield increased by 10 basis points, then the bond price change we get by multiplying the bond price minus minus the duration times the change in the yield, and we will get a negative 2.5. So which means the bond price will go down to 942 from 942.13 to 939.63. Now what we dealt with is that the yield was expressed in the previous example, and also the previous formula. We assumed that the yield is expressed with continuous compounding. However, sometimes we are faced with a situation where the yield is not expressed with continuous compounding. Instead, it's expressed with compounding m times per year. So we need to modify this expression for the duration by using the modified duration. The modified duration is basically the duration divided by 1 plus the yield divided by m. And people usually use the modified duration because it is seldom that the yield is expressed with continuous compounding. So why this measure is important? Well, if we are managing a portfolio of bonds, then we can construct a duration for the bond portfolio by considering the duration of the bond portfolio to equal the weighted average duration of the bonds included in the portfolio. And this will tell us how sensitive is our bond portfolio to changes in the yield. And the yield will change also as a result of changes in the zero rates or the spot rates curve. So the yield will not change only for no reason. There has to be some macroeconomic factors that affect the yield, the bond yield, in addition to some specific factors that affect the issue of the bond. Now, some usages of the portfolio of bond duration is that it enables the investor or the fund manager to match the duration of the bond portfolio with its bond with its liabilities. So if a fund manager or a bank that manages assets, and it also manages obtains liability, determining the duration of an assets will enable the company also to match its assets with its obligations. I will repeat here again. Assume that a bank that has a portfolio of bonds or a portfolio of loans. So these for the bank are considered assets, and the bank, to finance these assets, it issued bonds or it borrowed from someone else, or so it obtained a liability. Now the bank might run into a liquidity problem if there was a mismatch between its assets and its liabilities. For example, there is a liability that is due, but the bank does not have a liquid asset to pay back this liability. So constructing matching the duration of the bank's portfolio of assets with its with the duration of its portfolio of liabilities help the bank to avoid encountering such a problem. Now, we have to keep in mind that the duration will measure the sensitivity of a bond or a bond portfolio up to a small change in the yield. If there is a large shift in the yield, then the duration will fail to capture the exact change in the bond price as a result of the change in the yield. Why? Because the relationship between the bond and its yield is non-linear. The duration assumes that the relationship is linear, which is not the case. If we look here at two portfolios of bonds, one portfolio X and the other is portfolio Y. Now, small change in the yield will be captured to a large extent accurately by the duration. But if there was a large shift in the bond yield, and here it's important to keep in mind that the duration for X and the duration for Y are the same. Okay, now when there is a large shift in the yield, the change in the portfolio, in the price of portfolio X, will be stronger compared to the change in the price of portfolio Y. So that's why the duration is a good measure, but only for small changes in the yield curve. If there is a large change, then it will fail to match these or to accurately capture the effect of this change on the bond price. For this reason, another measure is constructed and introduced, which is the convexity of the bond. Now, the convexity of the bond is defined according to this formula here. So basically, it's the present value of the cash flows, or the summation of the present value of the cash flows, times the timing on which the cash flow will take place, squared, after we sum all these values, we divide it by the price of the bond today, and we will get the convexity of the bond. So to capture the effect of changes in the yield, not only we need the duration, but also we need to include the convexity of the convexity of the bond portfolio. So if there are larger shifts in the yield, it will capture that into capture its effect properly, and explain by how much the bond price will change. Now, if there is a shift that is not parallel in the zero curve, then also the convexity will not be able to capture that. So it only both the duration and convexity will be able to capture the properly and accurately the effect of the yield on the bond price if there is a parallel shift in the yield curve. What do we mean by a parallel shift in the yield curve? Let's say this is toward low yield. Now, a parallel shift will mean that the bond will all the yield will increase or decrease by the same value. Now, it is possible that sometimes the shift will not be parallel. So, for example, it looks like something like this. So, in this case, the convexity will not be able to capture properly the effect of the change in the yield on the bond price or the portfolio bond price. So if we want to apply or want to find the convexity using the bond in the previous example, we have here the cash flows that the bond generates, and we need to determine this column here. To get this column, we multiply the present value of the cash flow times the square of the time at which the payment will take place. So the present value of the cash flow discounted using the current yield times 0.5 squared. So we'll get this value here, and we continue to do the same process for the rest of the payments, and we will get 1.704. Now, to get C, we need to divide this by the present value of the bond, which we calculated earlier, and we will get the convexity is equal to 0.002 for this bond. Now, if this is the convexity, now we want to predict what will be the change in the bond price as a result of a change in the bond yield, by 10%, 10 basis points, or 0.1%. So using the previous formula, we multiply the bond price or minus the bond price times the duration times the change in the yield plus 0.5 times the bond. Well, this is supposed to be 0.02. Okay, the convexity C times the square of the change in the yield. So again, we will get a minus 2.5, which means that the bond price will go down by $2.5, and it will be 939.63. Now, what do we notice here? The change in the bond price is similar to the change in the bond price when we did not consider the convexity in the previous example. And this illustrates that for a small change in the bond yield, we will get we will capture accurately the change in the bond price by using the duration. But if the change in the bond yield is large, then using the bond the duration only to get or predict how much the bond price will change will not lead to an accurate result. That's why we need to also include the bond convexity to capture properly the effect of the large change in the bond yield. So that's it with respect to the for our discussion with respect to the bond duration and bond convexity. Thank you for listening. Assalamu alaikum.